Hi, a very good day. So I'm Amizi bin Western Lodge, and as you can see, this is a tool design subject, and I'm going to show you about my project 1 mold design. First of all, let's go through to the introduction first, which is mold design is a crucial part of manufacturing that shapes materials like plastics and metals into specific products. It starts by understanding products' needs, choosing durable materials, and designing key components like cavities and cores that define shape, cooling channels, and ejector system help improve production efficiency. Advanced simulation tools predict how materials will flow, allowing designer to spot potential issue. Early prototyping helps refine the mold to meet exact specifications. Techniques like CNC machining and EDM create precise molds, reducing defects and production costs. Modern molds can handle complex shapes, promoting innovation, collaboration among designers, engineers, and production teams is key. There's also a growing focus on using sustainable materials and process. Overall, good mold design enhance manufacturing efficiency and product quality across industries. Now on to the next part, which is objective. The objective of mold design include precision, quality, cost efficiency, and functionality. So first of all, for the precision, to create molds that accurately shape products to the correct dimension. For quality, to reduce defects and ensure consistent quality in finished products. While for cost efficiency, to lower production costs by minimizing material waste and cycle times. And lastly, functionality, to ensure the mold meets all necessary product features and requirements. So as you can see, this is the injection mold in plastic process. Injection molding is a method for making plastic parts. It starts with heating plastic materials like ABS or polypropylene until they melt. The melted plastic is pushed into a mold under higher pressure to fill it up. After it cools and hardens, the mold opens and the finished part is pushed out. Any extra plastic is cut off. This process is efficient, allows for detailed shapes, and create little waste. It's commonly used in industry like cars, electronics, and consumer products. So there are two types, which is injection molding and extrusion molding. So for the preliminary factors of mold design, first of all is clamping necessaries, which calculate the clamping force based on the project area of the part and the injection pressure. It's to ensure the mold can withstand the force without opening or deforming. Second, molding cycle, to aim for balance between speed and quality. The shorter the cycles, the higher the productivity, but may affect part quality if cooling is insufficient. Other than that, analyze the cooling time needed based on part thickness and material properties. So third, position and type of feed. Decide on the placement of gates and runners, ensuring even material distribution and minimizing potential defects. Consider whether to use direct gates, edge gates, or other configuration based on part design and size. Mold opening, which is lastly mold opening force, to ensure that the design can handle the necessary opening force without damage factor in the weight of the part and additional resistance from the ejection system. So there are two types sketch of injection molding. First of all is two-plate mold. The two-plate molds are widely utilized in the production of plastic bottles, particularly those made from PET, polyethylene terephthalate. And this application is favored for its efficiency and ability to produce high-quality uniform bottles. It's widely used due to design simplicity, cost-effectiveness, and easy ejection. Number 2 is three-plate mold, which three-plate mold commonly used for producing complex components in automotive parts such as dashboard, trim pieces, and housing for sensor and electronics. Other than that, it widely used in consumer electronics because it is ideal for intricate casings for smartphones, tablets, and other electronics devices that require detailed features. So now on to the next part, which is complete mold designing. There consists of 10 parts, which is number 1, core, where the component that shapes the internal feature of part, and number 2, cavity, the hollow space within the mold, and number 3, insert, where preformed components placed into the mold cavity before the ejection of the molten material, and number 4, parting line, where the line of surface where the two halves of the mold meet. And number 5, feed system, also known as the runner system, directs molten plastic from the ejection machine nozzle into the mold cavity. And number 6, ejection system. Once the plastic has cooled and hardened inside the mold, it must remove or eject. On to the number 7, mold shrinkage. The reduction in size of molded part as it cools solidifies after injected into mold. And number 8, taper, a slight angle of slope applied to the walls of mold cavity or core. And number 9, tolerance. The allowable variation in dimension and features of the molded part injection mold line tolerance are typically by plus minus 0.1 mm. And lastly, into the cooling system to control the temperature of mold during the injection process, also part of solidification, reducing cycle time and maintaining product quality. Now, let's go through to the part where I create my own mold design, which is this Ethnis design, where this logo represents Ethnis, a popular brand known for its skateboarding shoes, founded in 1986 by Pierre-André Senis-Sergues in France. Ethnis is recognized for its innovative design and commitment to quality. The brand also focuses on sustainability, which appeals to eco-friendly consumer. I designed this logo to express my passion for skateboarding. I wanted to capture the energy and creatives of the sport, reflect the community spirit, and inspire others. By blending my love for skateboarding with my design skills, I hope to create something that resonates with fellow skaters and represent our culture. So this is the two-plate mold of the plastic part. For the first of all, this is the two-plate mold drawing, and the second is the two-plate mold design. And there's the detailed drawing of the mold. So first is the plastic part, which is from the first preview that I show, and the second is mold cavity, third mold core and ejector pin. Lastly is the nut for the secure the hold of the pieces from the mold. And this is the assembly of the mold and an exploded drawing of the mold. Now let's go to the next part, which describes the sustainable elements to increase to life and awareness of environment. First of all, we have material selection. To the down point, which eco-friendly materials is choose tools made from sustainable, recyclable or biodegradable materials. Tools that use high quality metals or composites can last longer and reduce waste. Second, recycle components. Opt for tools that incorporate recycled materials, reducing the need for new raw materials. Second is we have maintenance practice, where regular maintenance, establishing a routine for cleaning, sharpening and inspecting tools help prevent wear and extends their usability. And we have proper storage, stores tools in a dry, organized manner to prevent damage and rust. Lastly, we have energy efficiency, where low energy tools invest in tools that use less energy or are powered by renewable energy resource, reducing the environmental footprint. And we have the battery technology, where use tools with efficiency battery system to minimize waste and maximize performance. As for the discussion, we have molds are vital in manufacturing for shaping materials. The two main types are two-plate and three-plate molds. Two-plate molds are simpler and more cost-effective, so suitable for basic parts, where three-plate molds are better for complex designs, multiple cavities or different materials. Key part of molds include the runner system, which directs molten material into cavities, and the cavity and core plates, which shape and part. Ejector pins help remove the finished part once it's cool. And designing molds also involve considering factors like draft angles, cooling efficiency and materials choice to ensure effective production. Lastly, we have conclusion, where molds play a critical role in manufacturing process, especially when it comes to injection molding. The reason for this is because they make it possible to produce intricate and accurate plastic parts rapidly. Selecting between two plates and three plate molds, for example, has an impact on the product's appearance and functionality, as well as manufacturing efficiency and cost. Aside from that, other important elements that are essential for maximizing mold performance and longevity include material selection, cooling design, and maintenance. Ultimately, in order to get high quality production result, we must comprehend the complexity of the mold design and its role. So that's all from me. Thank you for listening.